So, dear participants, we'll be starting with our next session. Thank you. Excuse me.
Yes, sir, you can start.
Yeah, I'm sharing the session, screen. Give me a minute. So just so I'm referring using the slides from Stanford course CS 231 Yan 2017. Okay, so already we have seen what is classification, what is object detection. Now let's focus on segmentation. So if you check it out, what is a segmentation? In simple terms, I can say the object detection I need to do through a bounding box, right? Instead of a bounding box, can you see my screen, please? Hello, it's visible, right? Okay, all right. So instead of a bounding box, I need to identify the pixels of the object that we are interested in. That is nothing but a boundary of the object, exact boundary of the object instead of the bounding box. So we have two types of segmentation: semantic segmentation and instance segmentation. Segmentation involves understanding what is given in an image at a pixel level. Okay, it provides a fine-grained information about an image. So with an segmentation, suppose this is a cat image. So what is an input image? If I ask for a segmentation model, it will differentiate what is a cat and what is a background. Okay, so if it can identify what is a grass, where is a cat, where is a sky, where is a tree, okay, then it's called semantic segmentation. Basically, in semantic segmentation, we are interested in the pixels values belonging to a particular instance. Sorry, a particular class, not about the instance. If you really want to do the instance segmentation, that will be another ball game. Means we have the multiple objects where we need to identify multiple instances of the dog separately. I cannot color them single as there are two dogs in the given image, or object detection has detected two dogs. I need to find the pixels involved with dog one separately and dog two separately. So you can see the semantic representation of a red bounding box with the red pixels, green bounding box with the green pixels, identifying two instances of the dogs. Okay. So in semantic segmentation, no objects, just pixels. Okay. I'm just trying to skip few slides. Okay. Now, basically, when we want to do the segmentation, in any of the things that we are discussing, try to understand, all of you are here because you are either interested in computer vision or a deep learning or video analytics, right? So when we talk about computer vision, pattern recognition, or image processing, okay, now these three areas are merged so much that there are no separations. But in earlier computer science development, they were considered differently. So whenever I'm talking about any task in a computer vision, we have two types of methods. One is traditional handcrafted feature engineering methods, and second is deep learning methods. So if you really interested in segmentation with the handcrafted feature methods like identifying edge, contours, pixel intensity, all those are the old methods. Right now, today my focus will be on segmentation using deep learning. or deep feed forward networks or deep convolution networks for or deep networks for segmentation. So here if you see the convolution, if you have understood the basics, in convolution we have the given image which is very of high resolution. Okay, but the when you do the convolution, your input size reduces. For the classification, the output size will be only one number or the n numbers based on the n class classification, and each number representing the probability whether this image belongs to that class or not. Means if you see the image, it's something like this. Input size is reducing. So suppose this is the input size. So after the convolution network is completed, output feature vector is something like this. Okay, basically in most of the discussions we show them with a tapper diagram. What's happening? Convolution is happening or some reduction of the, so we represent this as CNN, deep neural network, feed for a neural network, whatever the name we may give. But actually thing is input dimensionality is high, output dimension or the embedding size is very less. So what this embedding is, this is nothing but my feature vector. This feature vector tells which class it belongs to. Okay, it belongs to a cat or a dog. Okay, for representing this, it uses only one number, uh, one variable. Are you following me? So the output size is small and input size is large. So the problem is classification architectures that we use reduces the features spatial size to go deeper, but semantic segmentation requires the output size to be same as input size. But in semantic segmentation, I require the same image of same resolution n by m, and each pixel need to be identified as it belongs to an object or not belongs to that object, or what meaning it has. So here you can see in this scene, the grass, the sky, the trees all have the different semantic representation and have been identified as separately. So basically, how many colors you can see on the right side image is that many semantic meanings that we have attached to the pixels. So here green pixel on my semantic image or segmented image represents the grass. So, okay, so if it is a pixel belongs to grass and not detected as a grass, that is an error of the prediction. That is an error of the prediction. So basically, if you see, the input size is 3HW, the prediction size is HW, whereas normal convolution try to reduce the size based on the convolution size DHW and reduces the output. You can apply argmax, softmax, whatever based on the prediction, but that will not be working. That will not be working. We need to design a network with only convolution layer without downsampling the operator to make this prediction. So is this kind of network, if we design, it will be very costly. It is because lot of computations, because every convolution layer has the same dimension. The dimension of dimensionality or spatial context is not reducing. So it is computationally expensive, it is memory wise expensive, and this is not feasible. This solution is not a feasible one. But if I want to use this convolutions, the dimensionality will reduce, right? How I can do restore it? So there is two networks basically. One network will do the downsampling, another will do the upsampling. And this is how we are going to design the segmentation networks, most of the segmentation networks in deep neural networks. So the design network as a bunch of convolution layer with downsampling and upsampling. So this is the important idea of the segmentation. Okay, remember this. So basically, if I have to go to my MS Paint, how did we solve this issue of reducing the input size? We create another deconvolution network. We create another deconvolution network which will upsample and get back the original data. Means I can identify all the pixels that belongs to. So we have basically two networks. One is downsampling network, another is upsampling network. I hope the point is clear. Any question here? If you have the question, please ask me. So basically in segmentation, we can answer the questions like where is the cat? What is the location of the cat? What is the difference between where the pixels are belongs to cat and where the pixels does not belongs to cat in our this example. Okay. Now with this all mathematics that I want to skip for a now, because I have a limited time and I have to cover many hands-on experimentations, and I have to go beyond YOLO also. That is what our plan is. And even though we were focusing on the video analytics, usually on the normal scenes or the traffic one, today I have deviated it. Even I want to consider some medical imaging for the purpose. Okay. So please allow me to continue. So I'm skipping the slides quite enough. So people were asking about the detection models, right? Apart from yellow, we had the RCNN, fast RCNN. Okay, for masking, we got the network called mask RCNN. Okay, so we do the masking and get the segmentations. So this was the state of the art on the 2017. But however, you know that landscape has changed. Okay, let me go to the very important source of the uh, basically this is an article by an IBM. So here you can see some of the important nets that we use in medical imaging are UNets. Okay, they make use of skip connection. This is a kind of CNN technique to make the network deeper and effective. Okay, then we have the deep lab. Okay, so and then we have the PSP net. So I'm not going in detail with PSP net and deep lab. That is if we can provide an interested, sorry, we can provide the candidates, those who are interested, with the required pointers. Okay, let me come back to the same point where Prof Hassan has left us. So we have seen this ultralytic already. Now let's go to the segments. So here we have the instance segmentation ultralytic YOLO model. So basically, before I go further, I want to clarify the confusion, because a lot of things are coming and we may be confused. There are uh, some distinction that you need to create and try to understand. So what Dr. Hassan has explained you, this anaconda prompt is basically your own system. You have configured your system, you have created a uh, what you say environment called YOLO. For different projects there can be a different requirements, like different version of libraries may be required, maybe different PyTorch versions may be required, different Python version may be required. So for that already we know that we can create the different environments. If you want to list what are the environments available, you can use the command conda env list. Okay, conda env list. So these are the currently available environments that I am using. So by default, what will be the environment name? Can you tell me? Somebody can open the mic and tell me what is the default environment name?
Base.
Very good. Okay. So now what you can do here, same thing you can do on the any platform like Google Colab, Kaggle, or Paper Space Gradient. So what is this? Basically a Google Colab. Google Colab is running on a Google Cloud platform, which is very high and powerful resource. Okay. So you can follow the same step. Open the Google Colab. Okay. So right now I have an empty Google Colab notebook, right? When you do this step, you have the empty Colab notebook. So currently you are not even connected to any virtual machine. So even when you want to run some code, you will be connected to a virtual machine. Okay, you can for if I'm going to be very fast, you can just stop me. So it should give me the error because I have not followed the syntax. So when I follow the syntax, actually I can get the output. You can see that this is my machine, virtual machine resources. So my virtual machine is basically running a Linux based operating system or Unix based kernel. So all the commands that I can write here is my Linux commands. Okay. So if I want to know which directory I am working, I can write present working directory. So if you want to visualize this content directory, you can click here. If you want to list the content of this content directory, you can use the ls command. So basically there is a folder called sample data that is connected. So what resource I'm connected to? I got the disk of around 110 GB and a RAM of 12 GB. But if you really want to do the programming, the things that I want to do, like training the model, I need an NVIDIA GPU card. So NVIDIA is available to me in this environment or not, I can check with the command NVIDIA SMI. Okay. So when I run this command, NVIDIA MSI, sorry, SMI, NVIDIA SMI. So currently I am not connected to an GPU. So my uh, system is giving me an error. Now I'll go to manage session. Sorry, I'll go to manage resources. Sorry. Oh. Maybe I've used the 1 second. Give me a second. I need to connect my runtime to a GPU. So currently my GPU is being used in this this code actually. I think I need to disconnect from this first. Let me check whether my training is over or not, because I was training this code so that I will be able to have a short time. Okay. So my training results are in this folder, runs train. Run segment train. Okay. So what I'm doing right now is I'm trying to download a model file which is being trained by me in this Google Colab. Okay. So I'm downloading my model name best.pt. So currently, sorry for my interrupt. I will come back to the Google Colab once again. So what I've done is I will explain you later again, once again. Okay. So basically I have trained the model and I have downloaded the files. Okay. So when in next demo, I will be using this file instead of the YOLO 11 or YOLO 8 pre-trained model. Using a pre-trained model, I am going to use a custom detector. Okay. So here, if you see this environment, okay, this environment is already connected with GPU. This environment is already connected with GPU. Let me disconnect this environment or use the command here only. So you can execute the same command. If you do get the error like this, you are not connected to GPU. Okay. If you get an error like this, you are not connected to GPU. If you don't get an error, if you get an output like this, it means that you are connected to system. The same command you can even check on your command line on your system. Okay. If I have the NVIDIA installed properly, so I can check how many GPUs are available for my GPU based training with a command NVIDIA SMI. So if you see the NVIDIA SMI output, it will tell you which GPU you are using, what is the name of a GPU or the accelerator. Okay, how much memory it brings for a GPU memory, or how big tensor or the data you can load, or how many batches you can create, and currently what are the processes that are using it. So similar output you can see here. The name of the GPU I'm using on my runtime environment is Tesla T4. Is Tesla T4. Is that clear? So what is the amount of GPU memory I'm using? 16 GB, around 16 GB. Okay. Currently, no running process utilizing the GPU or GPU memory. Is that clear? So you need to be connected to GPU environment if you want to make use of GPU. Right now, in the beginning, I don't need a GPU. Let me go to the quick start. Okay. And take this command. Okay. Let me go to the CLI. Okay. So I can use this command to install the Ultralytics into my, for example, if I try to run YOLO here, YOLO is not installed here. It will give me an error. But if I do this, I install the Ultralytic package. If I install the Ultralytic package, Let me complete this package installation. Okay, it's done. Very good. So now if I say YOLO, so YOLO is available in this system now. But currently I have not given any task to YOLO to do it. So it will show me some help file and some other details. Okay. So it is telling me that YOLO can be used in a following format. So to run the YOLO command, okay, can you see clearly now? I hope. To run the YOLO command, you need to specify the task. The task can be segment, OBB, classify, pose, detect, etc. Then the mode like predict, benchmark, track, validate, export, train, etc. So if you are trying to do the YOLO task for segmentation, then you will use the segment, task equal to segment. If you want for object detector, you will use the task equal to detect. If you want a human skeleton pose estimation, then you will use the pose. Okay. According to the task, you will select the task. Okay. If you are training a model for segmentation, you will use the predict. Okay. That I want to predict and segment both. uh, Segment and predict the class, and arguments are the details. So where you can get these details, you can go to quick start and click on CLI. You will get all these details about the task to be used. Okay, so let me run the task. Okay, so here is a YOLO predict model equal to so and so, image size equal to so and so, confidence is equal to so and so. So here, when you don't specify the source, it will work on some default sample outputs. Okay, but if you don't use in current versions, if you don't use equal to symbol, okay, between the keywords, it will not work. In previous model, it used to be worked with hyphen, but these are in 11, these are both are violated, means cancelled. So the right format is to use this kind of command. Okay, so let me check my Ultralytics is installed already, and I can use the YOLO command. So to run the YOLO command, what you need to attach? You need to write something like exclamation mark. It means that this is not a Python command. This is a system command. When you put the exclamation mark, it's something like you are overriding the interpreter, and instead of a Python interpreter, you will be activating the system interpreter, and command line command will be executed on the system. Okay, now let me run some basic segmentation. Okay, so I have already written the command. You can just copy it as I explained you. So task is to segment. Model mode should be predict. The model I am specifying is YOLO V8 yes size model. The object need to be segmented if prediction confidence is above 25%. The image should be used from the internet, hyperlink or URL hyperlink. Okay, and the output need to be saved. Okay, so if you uh, currently you observe here also, here you don't have any image with name .jpg, but when you execute this, your YOLO will download this image, invoke this model, and then perform these tasks and save the result. Okay, so let me, Okay, can you see the screen clearly? If you have any problem, please let me know. So if you see what is happening, we have downloaded the model first from the Ultralytic. Then we have downloaded the image to be tested. Then image has identified certain objects. One person is there in the scene, one car is there in the scene, one dog is there in the scene, one backpack, one handbag, and time taken is 849.2 milliseconds. 849.2 milliseconds. The post process image shape was this. So basically, default image size that our YOLO model works is 640 by 640. Okay, but somehow the image size itself was maybe something different, so we could not get it. So now you just see here, you got new files. Doc.jpg, the YOLO model that you have used. Where is your result? Your result is in this path, in context of current this. Okay, in the current directory, from the current directory. Suppose you are very new to the programming, or you have some difficulty in developing and deep learning programming, so you can ask the Gemini how to display image in Colab. Okay, so basically it suggests me to use 2 or 3 lines. Okay, if I have to mount the Google Drive, I have to use this code. Currently I'm not using the Google Drive, I'm using my space content directory. So now my image path from this doc.jpg need to be copied to visualize this doc.jpg. So this is my path. If I run this, you can see the image very clearly. So let me reduce the resolution to show the full image right now. So can you see this image? Yes, no. So where is my answer? Where is my answer? My answer is in this path, right? Okay. So there is a run, segment, predict, and this is the doc.jpg which has an answer image. So this, because I have run the segmentation model, it need to have the boundary of all the objects: person, car, dog, backpack, handbag, need to be identified and labeled. Okay, so let me execute this. So this is my output with different colors. You can see the dog has a different color, person has a different color, backpack has a different color, car is very far and very occluded, but still it could detect it, because YOLO 8 onwards we can focus on small object detection. We can focus on small object detection. The same thing we can do on our command line also. Same thing we can do on our command line. I need to write my command. Okay, YOLO task segment mode predict. Uh, Dr. Zakir or Officer, is there any issue or comment thing that I have to attend?
Some comments are there, sir.
Okay, so I'm working on project object detection and behavior pattern recognition using camera and generate alert and send to the police for action. Which algorithm or tools used for the beginner level? This all we are covering is all fundamentals, all beginning. And definitely you have highlighted very important thing, that most of us are from faculty, teaching faculty or fraternity, and most of us are involved in research. Let me discuss how as a beginner I can do the research. Okay, but let me finish my syllabus first for the today's task. Is that okay? Can somebody thumbs up? Okay, fine, thank you. So same thing what I've done on Google Colab. The Google Colab environment is only different, but the things are same. Okay, things are same. You need not to worry about them. Is Are you following me? So same command when I execute on my local machine. So this is my current directory. This day 4 C colon user. Okay, and here my results have been um, generated. You can see this is a YOLO model, that is a YOLO environment that is being used. But you didn't find the YOLO download, image download, because it is found locally already. You have found the image already. Okay, and you have found the model also already. Okay, and the model is successfully loaded. Okay, so this model takes 42.6 gigaflop of computation. So because my GPU is weaker than the T4, my timing is different. My speed of performance is 2.9, but pre-process is 1.2. Total inference time is 1394.1 millisecond. Means my frame rate on this GPU is going to be very, very bad. But here, if you see, you got the some good performance. So someone asked in the previous uh, session that how I can defend my thesis and defend why I have used YOLO and YOLO 11. So you can focus on this area. When you change the model to YOLO 11, definitely there will be a change in the performance. Change in the performance. Why the change will be the performance is already documented in the literature. Most common answer is there is a some function to reduce the repeated bonding boxes. Means one object is detected with multiple bonding box, so we need to eliminate multiple bonding box and keep only one bonding box as a final one. Okay. For that, we used to use certain mathematical computations. The computation is called non-maximum suppression or NMS. All this used to become very costly. Like you can see on the Silo GPU, this post-processing was very costly. That's why you can go for YOLO 11. So YOLO 11 is faster than YOLO V8. YOLO V8 is faster than what you say, YOLO V3 or V5. Not only that difference, there are many things. If you want to discuss that, you can connect to us in person, uh, either through the chat group or in person, whatever. Okay. Are you following? Please respond to me with some chat box or the emojis. Where were we? So if I go to this segment, documentation, home, segment. Okay. Here, whatever Python example I may get for prediction, this is instant segmentation, right? So this code can be executed directly in Colab or in your local PC. Okay. So let me just, I have just closed or opened some Google Colab. Okay, now suppose this is my code which I copied from Ultralytic. If I run this, this will work. Okay, so how it will work? It will download some photo from the URL bus.jpg, and then it will be, so if I copy this URL into my local command line, I will get the second inference on bus. So my RoboFlow image prediction was in predict 6 folder. Okay. And my next bus.jpg will come in predict 7. Let us go to the directory, runs, segment, predict 6. Predict 6 as an image, which we have already seen on the Google Colab also. Okay. Are you following me or no? Similarly, if you want to run on bus, this is already executed. You can see the output is in predict 7 folder. And this is your images. Suppose you are doing the research using Google Colab or some material, then you can download these results. Okay. Or you can find the script to zip. Okay. It will give you the code which you can use, then specify run. You can download your answers. Are you following me? So you can make use of Gemini and make your life very easy. Because if you directly try to download a big file, okay, your browser process will be used. If you use this command, Gemini command, or whatever uh, code is being done, it will be done by Google Cloud, which will be more faster than the browser. Okay. So now let me clear the screen. Sorry, I'm on to Windows system, so I have to use the CLS. So now, if I have to use the video, then the video source should be specified here. Okay, I have the video called traffic.mp4. Okay, but I have not used the, okay, let me do the previous command. What was the source? Sorry. Let me run the bus.jpg again. I last time what I've done, I have done save equal to true, but now what I'm doing is show equal to true. Okay. It will automatically show the image. Okay. Instead of you going and checking there. Okay. So let me run on a video instead of the video name is traffic.mp4. Okay, instead of show equal to true, because sometime your video may be very long, so all the time you cannot watch what it is. Okay, so you will write save equal to true, means whatever execution will happen or detection segmentation will happen will be saved. Traffic, so something is wrong here in this command. Okay. Traffic spelling TRAWFIC. TRA. So it's performing frame by frame segmentation. Okay. So it may run for long. Let us look at the output. Okay. First, look at the video. How the video is. Video is like 1 minute video having the cars going in two direction on a particular highway. Okay. So now let me look at the results. Predict 9 was okay, but I interrupted it after few frames, right? So it doesn't have all the frames. If you want all the frames to be segmented, you need to run it for full time until it finish. Okay, so you can see the images. Uh, these are the segmentations. So this segmentation model is created on YOLO dataset. The YOLO dataset has around 80 classes. Okay, let me find out the details on sorry, Coco dataset classes. Okay, sorry. So these are the classes. Sorry. Can you identify one common object which is not here? Can you see the table fan or something like that? Can you see fan is here? Table fan or ceiling fan? Or you can ask the chat GPT. Fan is there? Yes, no. Okay. Fan is, if you ask chat GPT, or if you look into that, fan is not there in this. Okay. So now what if I run the object detector with fan? So what you are expecting? Object either need to be, there should be a false positive means it should be detected as the wrong object, something else, or it should not be detected at all. So right now, what I'm doing is segmentation. Segmentation on image I have shown you. Segmentation on video I have shown you. Segmentation on live camera. Okay. So let me adjust my scene with something called fan and try to identify what's happening. Okay. So which model I am running? Can you tell me? YOLO 11 or 10? We are running the YOLO 8 segmentation. Okay. And I have made save equal to true, means whatever detections will be done, that will be saved also. So let the model load. Let the camera start. Let me unlock my camera shutter. Always keep your camera shutter lock if it is not in use. Okay. The result is being not shown here. Okay. Why? My command does not say show equal to true. So let me write show equal to true. So this results might have come in you predict 10. Okay. Predict 10. So predict 10 contains this output. Okay, you can see the classes, you can see the uh, misrepresentation of the fan sometime, and sometime fan is not detected. Okay, so now if you want to see this live, you need to have this show equal to true. Okay, can you see the segmentation? If I move, the segmentation pixels will move. It will not remain same. Okay, so it's very real time. Even though hand is gone out of the person, it still shows. Okay, but if you can see non-maximum separation is not happening, there are two bounding box for one person, means the model is failing for this condition. Okay, let me stop this. Okay, by giving the interrupt. So if you are doing the code, you will be basically designing the clean code. So now if you want to develop something for which the objects are not being trained, usually segmentation labeling is very tedious. Segmentation labeling is very tedious. Sorry, can you see my screen? So okay, I think you are not able to see my screen. What I want to show you is something this. Okay, here basically I'm going to show you the one data set called car part segmentation. So here you need to, when you develop this car park segmentation, basically you draw the polygon for each object. Okay, something like this. So there are three objects: front bumper, front fender, and front door. So you design this using by drawing the polygon. How big data set you can create with limited resources? Very difficult, right? Yes or no? Are you following the problem? If you are to create a good detector, large number of images. Am I right? If you have to get large number of images, you need to do the large number of labelings. What are the other classes in this data set that I'm going using is bonnet, headlight, rear bumper, rear door. And what can be the use case of this uh, product? Why I need to create such model? It can be used in like insurance claim. If you're really planning, you can develop a one full application using this kind of model. This data set is already good enough. Okay, how good enough it is? It has 9,218 images and very well versed. Means the quality of the model I am expecting is quite nice. So here you can see I can identify the damages for the insurance use case. Are you clear with? So basically you need to develop a polygon for each item that need to be recognized. So what is this part is a bonnet. What is this part is a front bumper. What is this part? Okay, is labeled as headlight, but you can see it's a damaged one. Okay, so the labels can sometime doing the labeling for the segmentation may be very annoying. So in field of deep learning there is a special study called zero shot learning. Means if I find the new item, I should able to learn it automatically without getting retrained without getting retrained. So one such very popular model which works with zero shot is called segment anything model. Segment anything model, basically it can segment anything. Okay, if you have the, if I have to run this model now, you can identify that my fan which was not visible available in the previous detection is not segmented, can be segmented using an segment anything model. But due to the time constraint, I just skip the details of showing the demo. But you should remember that this is a one of the important segmentation model that can be used. It is trained on very large data set which contains more than 1 billion masks and over 1 million carefully curated images. Can you imagine this scale? 1 billion masks means objects boundaries and 11 million carefully curated images. Okay, so this model is very robust, very better than the. So what you can do, you can make a pipeline, use SAM to create a labeling of your data, then develop a specific YOLO detector. So how to develop a custom YOLO detector? You can just go to the, oh, my training is lost. No problem. But I can show you the new model that I already downloaded in the beginning. Okay, so basically, if you see, you what I'm doing is I'm connecting to the new Google Colab notebook for YOLO custom detection. Okay, I'm available with the what do you say, NVIDIA in this environment is connected. Remember that in free Google Colab, you should not always use GPU until and unless you are using the GPU for your code. Okay, till then you can disconnect the GPU or modify the configurations using setting. Okay, setting. Okay. So now, what is this? This is to record a variable or create a variable called home for our current directory. Okay, so that when we move from one directory to another, we can able to work. Okay, currently I'm not installing the normal ultralytic. I'm installing the specific ultralytic which supports the YOLO V8 only. If you try to run in this notebook YOLO V11, you cannot. If you want YOLO V11, go to YOLO V11 custom model and open the Google Colab notebook. Okay. So if you want this, I can just copy this to chat meeting notes. Okay. Just give me a time to show how to use a custom model. Okay. Basically, This is what already existing Colab notebook. Already I have explained you the CLI basic. Okay, this is already we have executed. Okay, let me skip this. Okay, you might have got the problem, right? Our image was very big. You can control the size so that it will be reduced, visible. Okay, then here basically we are doing another prediction. Okay, but here I'm not doing the save. I have not provided the save option or show option. Show will not work here on Google Colab. It requires a local machine. Save option the is also not used, but result you can visualize here. The result, confidence of the all objects, classes of all objects. Okay, and the mask data of your segmentation. Now, at the end of the today's task, I will show you and I have developed a code uh, to so that it will be more interesting and meaningful. So already Dr. Hassan has explained you how to create a data set. So one of the easiest method is download some plugin. Okay, like image downloader, install it. Okay, to your Chrome extension. Sorry, I want a mass image downloader. Let me go to, let me check whether this will work or not. Okay, right now, for example, I need car images. Or something called supercars. Okay, if my extension is enable, okay, so what I can do is just this extension is not suitable. Let me go to okay, be careful while using the Chrome extensions. If you are not using them for long, remove them. They can be one of the security threats sometime. Okay, so don't keep the extensions when they are not in use. Okay, so what I'm trying to tell you is how to collect a data set, common data sets. Okay, so if my extension is involved, installed properly, I can invoke mass image downloader. It has selected all the images in this. Then I can click on download. It will download a zip file. You understand? If you want to filter now only, you can filter that you want to deselect. Okay, or you want to select. So if you want to deselect, then click on download. Okay, so then you can upload them into RoboFlow for labeling. Okay, RoboFlow, after labeling is done, you need to get the uh, API key from the RoboFlow. RoboFlow has clear guideline how to copy API key and all. So now if I do this, it will download the complete data set into my Google Colab, uh, means Google Cloud platform. Okay. So already I have done the custom training for 10 epochs, and my best MAP for instances is around 89.9%. This is I've done for car part segmentation. Car part segmentation. Okay, this is the confusion matrix. Okay, what are the values of the confusion? This is the performance of the training. This is the validation results. Okay, now let me use the custom model which I have downloaded for this training. For this training. So what for this model is? Can you tell me what for this model is? Car part segmentation. Car part segmentation, right? So where I have downloaded the model in downloads. Okay. What was the name of the model that I have downloaded in front of you was best.pt and last.pt. Okay. Best.pt and last.pt. Let me come to my day 4 working directory on the desktop inside the FDP. Paste this model here. So now I'm showing you. So what I will do is I will open one image of the car. Okay. And run this custom detector model. So let me run the custom detector model first. So I want to run the custom detector model on a video. The name of the model is best.pt. The task is segment only. Mode is predict only. Okay. So let me run this model. It cannot segment anything in the scene right now. Like previously you have seen the person was segmented and other things are segmented. Right now this, oh, attribute has no, some error. Okay, let me do the differently. Let me upload the, let me use this. Okay, this code only. Okay, download one car image. Rename this as car. Upload this to my Google Drive. This is my Google Drive which I executed and the connection is right. So let me rerun to see that whether notebook is active. Okay, let me adjust the,
Bullard, screen is not visible.
sorry sir.
Your screen is not visible.
Oh, let me check it out.
Satish sir, it is visible to all. You may have to check at your end.
Okay, thank you, officer. I was very surprised. Okay, let me reshare the screen. No problem. Okay, so I need to upload that car image here from the local download. I would have downloaded a car image directly, but I need the URL in that case. I think some syntax error. Go to the okay, it's working. Now what I do is I use I need to upload the model also, which I want to use. Upload the model. What was our model? Did I cut and paste the model? Go to day 4, take base.pt. So I have to use the similar command. So I will copy this command and modify it. Can you see my screen, right? Yes or no? Hello?
Yes, sir.
Okay. So what is my model now? Best.pt I want to use. Okay. What is an image I want to use? Car.jpg. There is an error. It will not find the car.jpg because the spelling is wrong. Car.jpg does not exist. Okay. So let me re-execute this. Okay, so where is my image? In sorry, Control Z, run segment for predict and this. Predict to, what was the name of the input? Car.jpg. Okay. So it should be mentioning the parts. Okay. This is a custom detector. Okay. If I change this performance, this model from best.pt to YOLO seg, okay, the default model. What will be my output on the same car? Let me perform it. Perform the same action on the using the default model. What was the default model? Coco YOLO V8 yes slash seg. Okay. So the result is in predict.3. Okay. Let me have both results. No need to import the image again and again. Just use the, instead of predict 2, it will be predict 3. So different model, different output, different segmentation. Car. Okay. You can overlay both the outputs together. Okay. So that you can understand it's working, how good it's working or how bad it's working. How much time remaining, sir? May I get any answer from Dr. Zakir or Afsar? How much time remaining, sir? So this is our custom model, and this is our YOLO model. So YOLO model class is different, and the same thing I wanted to show on the what do you say, on the same scene, that fan is detected, not detected. But here also it is very clear that the parts identified in both the detections are very, very different. Am I right? Yes or no? So now let's go to, as a researcher, what we will be trying to do. For example, I have taken an example of image segmentation on MRI data. I started with some random queries. Okay, so I write image segmentation collab notebook, unit collab notebook. Finally, I landed with some output, something called, this is an MRI brain data set from Kaggle. Okay, and I found out some Google Colab notebook. Okay, and some resources on PyTorch. Okay, now as a researcher, what I should do? Sir, can you tell me how much time I can consume? Hello.
Pardon, sir?
How much time is remaining for me to complete the mission?
10 more minutes.
Okay, only 10 minutes.
If
Okay.
you need little extra, we can request the participants.
I want to show you the complete code development or the code review of the brain MRI on UNet. If you allow me extra 5 to 10 minutes, with your permission, sir. What audience say?
Yes, sir. Yes, sir. Sure, sure.
The audience can give a thumbs up.
Yes,
If
sir.
you
I'm
Yes,
not
sir.
getting enough responses to extend for next 10 minutes.
Okay. Okay, sir. I see a positive response. So
Okay.
I will try to stick till the end of the demonstration.
Okay. Thank you.
Thank you,
So
sir.
one of the very important thing for researcher to note, you should note down this URL. Okay, PyTorch Hub for researchers. Okay, this is very, very important repository and very quality product projects. It's not done by some FYP or what you say local list institute or some random people. You may get very high quality products here, sometimes very disappointing also, but this is a place to look for some of the inputs for your research. For example, someone has asked me for what you say, video classification network 3D. You can find a 3D resonate here, start working with it. So let us think. I have identified one resource for my project called UNet. Is a segmentation network that I have told you before while explaining the IBM notes. You can read for more detail. So it's a FCN architecture. We don't call it CCN because it's upsample and downsample. Upsample and downsample. Okay. So let me go through this one by one. So the main resource will be on GitHub. This is a whenever researcher want you to do some extension of their research and use their research, they will create they will share the code and data with you. Am I right? So suppose this is all the details that we have. Okay, then you can take this link and open it for yourself so that we can run the code. Are you okay with it? So when you click on open in Google Colab, your notebook will be ready to launch. Okay, before this, you can find some even explanatory articles which will explain you what is UNet, how it is being designed, even a snippet of code. Everything can be is there. So you decided to do medical image research using UNet first example. Okay, then you can extend it, modify, try, change. So let us identify the changing factors. Like I have explained you the 6 steps in the beginning. Whatever project you take, whatever libraries you take, you have the 6 things to do, right? You have to develop a architecture. Architecture is a unit. This left side shows the downsampling, right side shows the upsampling network. Okay, we need a data. Okay, and the code to load the data, the hyperparameter setting. Then we need to decide the network. So how you can design the network? So this is downsampling network, this is upsampling network. Okay, our unit is basically defined in two parts, downsample and upsample. So this is a network definition. So you can change the layer, change the data set, change the parameters. You can come up with your own new network. Okay, but you need to design appropriately. Like I have told you about CNN calculator before, accordingly. Okay, then you have trained the model, you have defined the network, you have trained the model, then you can do the segmentation. So let me go for the Google Note book that is available to us here. Okay, using this link which I've shared with you. Okay, if you open this network, this link, you have the inference code using a PyTorch. So what is the inference? The model is already developed. You need to apply it on certain inputs and perform either evaluation or develop an application. So how to use any code that is available? Okay, first thing that you need to do is you need to identify the code is developed in which platform. For example, if you have the code file with .pt, .pt means it's PyTorch. Okay, if it is TF, then it's a TensorFlow. Then there are so many types of extensions that you have already seen during the discussions, right? Like ONNX and other models. Okay, so depending upon the type of model, your file will change, extension will change. Okay, so now where I was. So this is the simple code available to you. You don't know what to do with this code. Okay, let's run first line. So it will ask you to run anyway. So now I will tell you how to make use of this further. So this code looks something like, now what happened? After I execute this, the model was downloaded. Okay, and the variable model is initialized. The torch torch package is imported to my environment. So already the model is that I want to download, I want to use is this. This is a model name, and this is the net architecture that is used, and this is the input it will take. Okay, this is the output it will produce. Means it will take a 3-channel input and produces an 1-channel output. Produces a 1-channel output. So in my PPT, I have shown you 3 into W into H will be transformed into 1 into W into H. 1 into W into H. These are the pre-trained model that I am using from the PyTorch. Okay, now what I want an input data. So this data, okay, let me open my notebook, modified notebook for this. Okay, very good. Let me stop. I'm really apologetic for having so many tabs open. Basically, my flow is from left to right. The moment I reach the right, I have to stop my presentation. So right now, we have loaded the model. We download the image. So currently, you don't have this code in your Google Colab. So can you type this code or just copy from the chat window, which I am going to share with you? Okay, so basically when I executed this code, what I got is this image was downloaded. So what I want to do now after executing this code, if you are downloading first time, you will get the message that image is downloaded. When I execute this code, you will see what is this in this image. Are you following me? Then what I'm going to do right now is I'm going to perform the inference. Inference means I will load this image into GPU, into a tensor, and call this model and get the result of this model onto this image. Is called inference, right? So I open the image. Okay. So my file name contains my new image. I call it an input image. Okay. I define how to load it to the tensor, means load it into the GPU. Okay. Then I will try to check whether GPU is available or not. If GPU is available, load the model to GPU. Okay, load the data to GPU and do the inference. So this is an inference line. Okay. Sorry, this is an inference line. This is loading the model to the GPU. This is the loading the model to the GPU. I'm checking whether there is an CUDA available. If CUDA is available, load the data to GPU, load the model to GPU. Okay, and then input batch is load data to GPU. What is transform function? Sorry, it's not a C. Okay. Then this is load model to GPU. So currently, if my GPU is not available, either it's going to connect to GPU because I'm demanding it, or it will give me an error if GPU is not available. So what it means now, it is able to load the tensor and produce the result like this. So what is this? Can anyone tell me what is this? This is a segmentation image mask. This is an segmentation image mask. Okay. So it is what was the whatever the image was there, it was transformed into using this transform function and loaded into GPU. We got the inference. After inference, I took the output and displayed it. This is just a tensor. This tensor is having of rank 3 with 1 into 256. If I have to, you can this is not there in your notebook. Can you type this line? I want to truncate and check the shape of the output. Check the shape of the output. Yeah, we'll take up the questions after 5 minutes. This is not very long notebook. Okay, and I'll share the complete notebook also for your reference for later use. So right now I want to visualize it. So what I've done, I need to convert this rank 3 tensor into 2 by 2 matrix. For that, I'm going to use a squeeze function. One dimension will be reduced. then convert it into numpy variable, then I will plot the show. So this is the mask. What this mask is telling, this is the area where the tumor is present in this image, according to the data that you got, right? So now, if you change the color map of the same image, you can see how this is looking. So this non-blue part is a tumor part actually. But now I want to verify this detection is good or bad. How you can identify it? Only if you superimpose it. By looking at side by side, can you tell some anomaly here? Can you tell any anomaly, please? Anybody? What is the problem? In binary mask or the segmentation, you can see some part is segmented outside the brain MRI. Means this model is not performing well. This model is not performing well. How you can visualize it? By putting the mask. So now suppose you want to evaluate a data set. So you add the code now. Bring the complete data set, evaluation data set, make the loop, perform the analysis. So like that, if you change the 2 or 3 segmentation nets for a particular same task, you can get one evaluation paper. Okay. Apart from that, you can, apart from Google Colab, like I told you about, this is a main data set. You can click on code, then find out a suitable code with most of the stars and study that. That also can be a easiest way to start. Here only thing is you need to sign in, nothing else. So once you sign in, whole code is available. The output produced by the previous work is also available. Okay. So basically they are again using the MRI data set. Okay. You need to just run it. Okay. Just click on play. Nothing else. So then you can keep on modifying the code until, so here this is a network, right? So you can change the networks, you can change the layers, and you can change the loss function. Okay, you can change the activation function, and you can gather the results for your preliminary research. For your preliminary research. So once you modify, if there is any error in your code, you can just look into the forums where the code is there, or can look into the chat GPT. Then after you train the model, you can go for evaluation of the model. Then you can benchmark a different data sets related to same task. So this is my training curve by Kaggle. So I can tell you, most of my mentees, those who had very short time, have done their complete research, or 80% of their even PhD on Google Colab. Kaggle, on Kaggle, not Google Colab. Okay, so here there is a test circuit also. You can see what is the input image, what is a true mask. There is a no tumor here. What is predicted is this. What is binary predicted mask is this. So based on that, you can evaluate some metric, and you can publish the result. Okay, with this, I want to end my session. I have many things to discuss, but let me end my session on this point. I'm open to the questions for another 5 minutes if you are interested.
Rima sir, we have a few questions in the chat.
Yes, sir. You can read it for me, please.
Where can I get the image fusion codes? Can we get some reference links?
This is basically you can develop on your own. This is very simple code I have done. What I've done is very simple, just overlay. Overlay means I'm putting both the MATLAB images in same not MATLAB, Plotlib components in same image, and when I show it, it is getting the overlay. Now, if you really want to identify how good or bad it is, you can calculate the number of pixels in input image. Sorry, I think my screen is not shared. I'm really sorry for that. I'll re-explain the answer. Can you see my code now, please, sir?
Yes, we can see your screen.
So see, my input image is an input image, which is in background. And this is a binary mask that I have generated after the inference. Then I keep the opacity. So if you are not well versed with the functions, you can directly go to the wiki library and check the function details. Okay. Or you can use the Gemini also to get the function or context help. If you are using the Visual Studio Code also, you can, when you type the function, if the proper library is loaded, it will show you the next parameters and their context. Okay, so basically I'm just overlaying the two images into same object and trying to show it. So now if you are interested to study further, you can calculate the number of pixels inside and outside, actual tumor and non-tumor based on the mask available. Like you know that already the masks are available for truth value. Okay, and binary prediction. So basically if you see, if you develop your own method, you will bring the fourth column here. Okay, fourth black image showing that how well you are able to manage, and ever should be very close to true mask. That is how you can develop the code. So developing code is not an issue, sir. Nowadays, even ChatGPT is a more than a mid-level programmer. Just try it. Or in fact, lot of time I am using the Gemini or ChatGPT develop module also.
Sorry to interrupt, sir. My dear participants, there is an important announcement at the end. Please stick with us. Okay, sir. Continue your explanation.
Yes, sir. My answer is sir. If you have any more thing to ask, please proceed. I will share this code with you, the modified code. Okay, you can try this. Okay, and that is the answer to the Dilshad what I'm trying to say. Anything else?
There are no more questions. Is there anybody having questions in the audience? You can unmute and ask. So I believe all the clarification has been received. Thank you, sir. That was a very wonderful and enlightening session, and very practical and implementable part of this session. Okay, thank you once again. I would like to make an important announcement to all the participants here. That is, attendance, 80% of the attendance is must in order to procure the certification from the ATL. So I request all of the participants to join in time to all the sessions and stick to the end of the sessions. And kindly fill the feedbacks after every session. That is also an important part of this. And last day of the FDP is scheduled on Monday. So we are having 3 sessions, and we will be starting the sessions from 2 p.m. onwards on the last day. So kindly make a reminder for yourself in your Google Calendar or any other calendars. And there can be a slight shuffling between the sessions. Maybe the last session may happen a little early, and okay, depending on the resource person's request, it may be rescheduled. Timing remains same, but session may go up and down. So there is a research writing important session at the end. So that's the final outcome what we have to do after this FDP. Ultimately, we have to bring out some outcome from there. So the research what we are doing, and that we have to produce it. Okay, that is why this session is also a very important part. So kindly I request everybody to make a note of it. So in the last day, depending on the session lengths, we may see how to declare the breaks. And finally, the assessment will be there after the last session, that is session 13, will be followed by the assessment. 80% of the 70%, sorry, 70% marks should be secured in the assessment. So it will be an online quiz. Okay, so please make a note of it again. And that will be followed, the quiz will be followed by the valedictory program, and we have a chief guest, and the valedictory will be starting at 7 p.m. and we have a chief guest from Amazon machine learning scientist. He is okay, very renowned person. So hopefully everybody will be joining us on the last day on time. So thank you once again. Today I would like to give a special thanks to our audience that to stick extra 15 minutes based on the even after the scheduled time is over. And thank you our resource person for showing the interest to the completion of the demonstration. Okay, thank you all once again and have a good night.